Hi guys, you welcome to my channel. So today I want to take you guys through all you need to pass and make A in your physics as a Waec student or a Waec teacher. Now this video is basically not for you if you are brilliant or you are a teacher teaching in a school that has a lot of resources, more than one teacher. This video is not for you. If you are the type that you don't know book, you don't know anything in physics, you are just not an average student, like extremely dull. I'm sorry to use that word. The video is not for you. This video is basically for somebody that wants to make A in physics. So either you are brilliant or you don't know anything in physics, you are a good teacher or you are a teacher that you are second guessing yourself, this video is for you. This video will talk about everything that you need to know in order for you to make A in physics as far as Waec is concerned, and not just to tell you what to do, but to also show you how to do it. So basically, the video is focusing on two things: to tell you what to do and how to do it. So let's get started. When it comes to physics Waec exam, basically, you and I know that we are looking into three things. These three things, if you can understand what they are looking out for and how to give them those things, then you are ready to get your A without any form of runs or what have you. So what are these three things that we know, you know, and I know? They are practical, objective, and theory. These are the three things that he wants to test us on. And ability to give them what they are looking for in these three things is what will make you have that A. So what are they looking for? Don't worry, just stay with me. I'm going to break everything down to the best of your knowledge, no matter how dumb you might think you are. If you are worse than I do as far as physics is concerned, then don't worry. Now, let's start from the practical. When it comes to physics practical, is one of those areas out of those three areas that I mentioned that can guarantee you success in your exam. But a lot of teachers and students, they find it difficult navigating this area. Why? Because they don't know the key factor to look out for in preparing for this area of physics. And that is what I want to explain to you now. Now, when it comes to physics practical, what and what should you look out for that examiner typically wants from you, and how can you give it to them? Now, let's go into how they set the questions of physics practical. On physics practical, the question is always three questions, and you are to answer just two. Out of these three questions, I'm going to divide the entire area in which examiner can bring up practical for you in physics. I'm going to divide them into four basic areas. By dividing them into these four basic areas, I'm going to tell you why the classification is like that. Number one is mechanics. Anything that has to do with force and balance is under this area. Number two is optics. Anything that has to do with light or image is under this area. Number three is heat. Anything that has to do with temperature and energy is under this area. And number four is electricity. Anything that has to do with magnetism, electromagnetism, charge, and what have you is under this area. You see these four categories, one of it is very constant, that you cannot escape it, and that is electricity. Now, do you know why it is so important that you cannot escape electricity? The reason is because the entire aspects of magnetism and electromagnetism, charge, all those areas, they are difficult for you to prove the experiment or theory that one wants to verify under them while you are in secondary school. So because it's difficult for you to carry out experiments to talk about those theories under those areas, we'll all try and look into what we refer to as something that is achievable for you to come about with in secondary school. As a student or a teacher teaching secondary school, this thing you should be able to do it. And when you look at it, all we are looking at under electricity, as far as electricity practical is concerned in Waec, is basically Ohm's law. I know somebody would probably argue this, and I know you don't believe. Calm down. Let me show you why. Why is it that everything electricity in physics, as far as Waec is concerned, is all about Ohm's law? This is because when you talk about magnetism, electromagnetism, when you want to talk about charge, when you want to talk about application of charge, when you want to talk about circuits, and you want to go in deeper to make it more useful, then you need to start dealing with some A-level theories that you yourself are not exposed to yet. You need to start dealing with some sophisticated apparatus that you yourself will find difficult to handle, or that is not something viable for a secondary school to own. Do you understand where I'm coming from now? Because even the basic ones that they are asking you to use, some schools, they will still have to do what? Have to get it on the day of the practical, or ask the teachers to find their way around it. So, not to now talk of sophisticated ones. Do you understand where I'm coming from? Even the basic tool that you are using to carry out the said Ohm's law, some teachers do not still understand how they work. Do you understand where I'm coming from now? So for this reason, all theory experiments under electricity that you are expecting, they are basically under Ohm's law. But examiners are not stupid to just give you experiments to verify Ohm's law completely. No, that would not happen. And they are not what? You should not be expecting that, because they are not going to do that. So what should you be expecting? What should you look out for? This is what to look out for, and this is what to expect. When you are studying electricity in physics, you need to understand what we say. When we say Ohm's law, what are the things we are talking about? We're talking about resistance, we're talking about current, we are talking about voltage. Now, sit back and look at the whole of the topics that you covered under electricity. How are they relatable with all these three things? That's where you get to see, okay, I think there are some tools that we use in testing or measuring resistance. For example, when I want to know the effect of resistance in a conductor, we use potentiometer, we use meter bridge, we use rheostats. Are you seeing it now? Okay, there is a conductor. Aside from conductor directly towards resistance or current or voltage, is there anything that resistance is also depending on? Okay, resistivity is also there. The length of the conductor is also there. Why am I mentioning all this? Is for you to have idea on how examiner can twist things. You can see that all the other thing we are still talking about is still under Ohm's law. I guess where I'm coming from now. This is what you need to understand about electricity. So, how does resistance relate with this? How does it relate with this? And for you to make things easier for yourself, just write down the following: potentiometer, meter bridge, Wheatstone bridge, rheostats, resistor. Write those 5 things down. When you write those 5 things down, you want to study them to understand how they relate to each other. So, and if you want to really know how they relate to each other, write down the formula that connects resistance and voltage and current. When you do that, write down the formula that now that connects resistance with other factors that determines resistance, such as length, area, and resistivity. This will help you to know how to go about things under electricity. However, I get you. I'm going to show you how to go about it, because I have come up with different form of experiments to quickly look at all these things to the best of your knowledge before we now attempt the pre-practical. That will make you understand all area of electricity very well, and you'll be able to handle the exam with ease. Now, to make it more complex, there's another area of electronics that examiner always want to use to advance Ohm's law in a bit. And what area is that? That is what's it called? Basic electronics, semiconductor. So when you talk about semiconductor, sometimes examiner wants to bring in the concept of diode into Ohm's law, and that can make it kind of a bit complex. How? It's also simple. When they are asking you to make use of diode, what diode? LED, light emitter diode. If they include it in your apparatus, how do you go about it? It's quite simple. Am I making sense now? We are also going to look into that. That's if we want to probably look into reverse bias or forward bias. Don't worry, I got you. All you just need to do is to follow this page. So subscribe now and also turn on your notification bell, because I already have enough experiment to explain all these things to you bit by bit. So that's that for electricity. If you can look into all of those things, you're already prepared for anyhow, anywhere they want to take you to under electricity practical. Now let's look at your number one question. Oftentimes, your number one question for the practical usually being mechanics. Now, when you look at mechanics, what are the areas of mechanics do you think you can easily handle experimentally at secondary school level, either as a teacher or as a student? Remember, I said either you don't know anything in physics, I'm going to make this thing so simple for you to understand. For the sake of those who really they do not know things like that in physics, let me take you through. When you talk about mechanics, we're talking about motion. Basically, we are talking about motion. We are talking about forces. That is equilibrium of forces, frictional force. Do you understand where I'm coming from now? All these are what we talk about in mechanics. And if you flash back and look at things so far, from now till the time that, if you just flash back to the time where we have been writing Waec down to today, you get to see that this mechanics question is always revolving the following apparatus: retort stand, pendulum bulb, mass, meter rule, thread, stopwatch. These are things that this experiment is always revolving around. So when you look at these things, you get to see that basically what really talks more about forces in physics, they are friction, motion, and equilibrium. When you talk about forces, go and look at all of the topics in physics, you get to see that when we are talking about force, we talk about force in motion. And when I say motion, I mean linear motion, I mean simple harmonic motion, I mean circular motion. And equilibrium of forces. Am I making sense now? These are areas where we talk about force. Am I making sense now? So for easy understanding, mechanics is basically you studying forces. Now, how can we now experiment this? Now, we can now look at things. When we talk about circular motion, experiment for us to prove circular motion might sometimes need the knowledge of A level, because we might want to be talking about rotational motion. And when you're talking about rotational motion, you might also be talking about the moment of inertia. Am I making sense now? Which is a bit complex for secondary school students to understand. So that makes you look away from testing or carrying out experiments under circular motion. However, we might want to look at experiments under what? Linear motion. And for us to look at experiment under linear motion, instead of us looking at experiment directly about linear motion, we look at experiment under friction. Am I making sense now? So, and that's quite simple. Do you understand where I'm coming from now? So you might also be thinking, okay, where else can we look at simple harmonic motion? And here, they cannot make things kind of what different from what you have been seeing. Instead of using pendulum, they can ask to use meter rule. Do you understand where I'm coming from? Instead of you starting your measurement from a very long length, they can ask you to start from the very short length. These are basic things that you need to understand about all this practical. And if the examiner wants to make it a bit complex, they can take it to machine, where you are not going to be talking about pulley, because all these are basic experiments that the apparatus are available for you as a student in secondary school or as a teacher that is teaching a secondary school student. Don't worry, I've also arranged some simple experiment that will make you understand how all this area works. All you need to do is to subscribe to this channel for free and turn on your notification bell. Now, aside from that, we now look at what? Optics, which is the second question. When you talk about optics, what are the things they want you to look out for? Is basically prism or lens. So if you understand that these are the two things that the experiment will be focusing on, then all you just need to do is to look at how all these things can appear. Like in how many ways can you twist question around these things? Instead of them to give you, what's it called, only prism, they can give you prism and what? Plane mirror. Do you understand that now? When we cannot be thinking about, okay, corner reflector, that will be the max of it. Okay, they won't talk about lenses. Okay, they might be looking at, okay, convex and concave. Oh, okay, when will the image be formed? When can the image not be formed? These are the things that this question will be surrounded with. So prepare your mind for it. However, I got you as well. We are going to be talking about what will make you understand what to see, and when you see it, you'll be able to know that, yes, I'm on the right track. Then, lastly, is the it. The it question usually be question number 2 as well, because question number 3 will not change. And oftentimes, question number 1 is always meekness. So, question that is likely to change for you is question number 2, to either what? Find it to be optics or find it to be what? It. Do you understand where I'm coming from now? So, sometimes your question number 1, which is meekness, so lest I forgot, can also take you to comparing mass and density. You know, we always say that no matter how much the mass of an object will be, the density remains constant. Examiner might want you to test that at times. And they can wrap it up. So if you talk about density, automatically they want you to talk about surface tension. These are areas for you to prepare your mind around under these topics. So for it, obviously, it's very, very easy for you to go about it. Is it how you want to talk about determining what? Your specific heat capacity, or you want to describe the Newton laws of cooling? These are basically two things that is quite obvious under what? Under it. However, examiner might want to take you back to what you must have forgotten in your SS1, looking at expansivity. Now that you already know all of these things that examiner will be looking out for in your exam, as far as the practical is concerned, how are you going to do it? Now, doing it, you have to focus on what examiner will collect from you to examine you to know that you've done the right thing. And what are those things? Just 2 things. That's your reading and your graph. So when it comes to your reading, what exactly do you want to understand about your reading? What are they looking out for? in your reading, one of the things to look out for that a lot of people they overlook it is the number of decimal places that each of your reading should be. The reading you got directly from the calculator, from the apparatus, how many decimal places do you want to have it? The reading that you got using your calculator, that has to do with evaluation, to what decimal place are you putting that? The value they gave you in the question, to what decimal place are you to put that? All these things are what you overlook, but they are things that count. Now, another thing that can take a lot of huge math from your reading is canceling or shading. So these are things that you will probably not pay attention to, but they are things that matter. So as a teacher, preparing students for this exam, these are things that they should watch out for. But how do you know the right things to do? Don't worry, it's part of what we are to cover. You are going to get that clear before you write your exam, because you are to make A's. Okay, the second thing is your graph. How are you going to plot the appropriate graph? Plotting the appropriate graph, there is something that you have at the back of your mind. But that thing that you have at the back of your mind is not as important as these two things that you forgot. What's that thing that you have at the back of your mind? Your teacher already tell you, or you have been told, that your graph must speak what? 3 points. Some will go to the extent of saying those were points that you are not going to be picking. There has to be alternates. Are you getting this now? So if they are going to be alternates, or you have to be what? You have to pick 3 points. You see, those two things that they've told you, they are not as important as these two things that you overlook. And what are those two things you overlook? Is that, number one, is that your graph must cover 2/3 of your graph paper. I'll take it again. Your graph must cover what? 2/3 of your graph paper. Number two is that your slope, that is what you pick to calculate your slope, must not be small or too big. So you have to be in between. So how do you get all of these things done successfully? If you can get them done successfully, there are some experiments that the nature of the experiment would not let you have 3 points picked. You have to know that. So if you are sticking to the rules that it has to pick at least 3 points, what will happen in such experiments? You probably think you are wrong. Obviously, you are not wrong. And that's why I want you to get it cleared now. Am I making sense? So, does that mean you should not watch out for what? Picking 3? Of course, you need to watch out for it. And that's why you need to know how to watch out for it, so that you will know that, okay, for this thing to have picked 3 is the nature of the experiment. It's not as if you have done the wrong thing. So, I have covered a video on how to plot a successful graph. And I'm going to add the link to the description part of this video. So everything that has to do with you plotting graph is what I've explained there. From picking your scale, writing your title, down to plotting a good-looking graph, all of that has been covered. So there's no issue talking about graph again. What we want to focus on now is your table. And we need to get it right. To what decimal place should this one be? To what decimal place should this one be? So if we are able to get all these things done successfully, your practical is good to go. But before we go on practical, last thing I would like to tell you is this. When you are doing your practical, number one thing that you should have at the back of your mind is that physics practical is do as I said. I'll take it again. Physics practical is what? Do as I said. You don't need to have practiced the experiment before that particular time you are having the exam. All you just need to do is to exercise extreme patience as a student. When I say exercise extreme patience, is that be calm. Read word for word and do what they ask you to do at every point in time. Don't pre-answer any question. That is, within yourself, don't have any answer in your mind already. Do you understand? Why we always need to have probably practicalized that experiment before the time is basically for you to work very fast. But if you have not encountered that experiment before, it's fine. You can still carry it out successfully. Just interpret the question as they ask you to do, and take the reading because they are telling you what to do at every point in time. That's what makes physics practical as simple as possible than any other practical out there. Any other practical out there, let's take for instance chemistry. You must have idea of what the end result should look like. You must have idea of what they are asking you to do for you to carry it out successfully. If you have not done chemistry practical before, you can't go to the lab and get it done for the first time. It's not always easy like that. But for physics, either you've done it before or so long you can read and interpret, you're good to go. So in those experiments I've piled up for you guys in order for us to look into, before we look at the pre-practical, before the practical itself, they are going to help you to know and understand how to carry out physics experiments. All I need from you is not your money, but I need your time, your willingness, and ability to subscribe to this channel for free. Just hit on the subscribe button. Finished. Turn on the notification bell so that when I drop the video, you get notified. Comment whatever you have in mind. You have a question, you have a request, make the request. So all of these are what I only want from you. And when you see somebody that might need this video, share it to them. So this is this for the first part. Now, the second part, which is the objective. How are they setting their objective? How are they setting their objective? How are you going to know what to expect from the objective? I would like to make that in another video so that I'm not going to take much of your time with this. And till the next time where I'm going to drop the next video on this said topic, don't forget to subscribe and share this video with other people. Turn on the notification bell so that you get notified when I drop the next one. Thank you so much for your time. I so much appreciate you guys. Until then, let's keep